Streams are a great way of sending large amounts of data to a client in much smaller chunks. They're perfect for things like sending large lists, or a great example is with the ChatGPT service. When you send a question, rather than waiting for the entire paragraph to load, it actually sends the data back one word at a time. Now, they're not using streams, they're using server-side events, I think, but the exact same thing can be achieved with GraphQL with the stream directive. So today, we'll look at two different examples. The first, just using dummy data to understand the concept of streams and how it all works. And then finally, we'll build an actual chat interface, sending data from the OpenAI API all the way to our client, one word at a time. So stick around to the end to see both examples. So let's go through the basic setup of this example. I've got a GraphQL Yoga server running on the back end, and I'm also using Create React app to render a front end. I've got one resolver at the moment, messages, which just returns an array of information. And then we've got a schema for that. In the React component, I'm sending this query to get all of the messages. And you can see when I refresh, I get A, B, C, and D come back, which is what I'm returning in my resolver. But let's set this up to work with streams instead. Now, the first thing we want to do is GraphQL Yoga does not support streams by default, so we need to import a module to make it work. Now, the module we need is called useDeferStream, and it comes from GraphQL Yoga's core package, although you'll need to install it yourself. Once we have that, we can use it as a plugin inside Create Yoga. Now, looking at the docs for defer and stream on the Yoga website, we can see that it gives two examples. The first is to use async generators, which are an option. So you can just loop through each piece of data that you want to stream and yield that character back to the client. And in this case, it's just using a dummy set timeout. But they recommend not using this because it can cause a few errors like locking the server up or getting you into kind of infinite loops. So instead, they recommend using a package called Repeater, which is also available from GraphQL Yoga. So with Repeater, in this example, rather than returning the data itself, we return the repeater instance, and it gives us two methods, push and stop. Every time we get a new piece of data and we want to push it to the server, we call push. And then once we've pushed all of our data, we can call stop, which will close the connection, and then everything's finished. So let's implement Repeater in our own resolver. So the first thing we want to do is import a new module called Repeater from GraphQL Yoga. And then rather than return the messages directly, we'll just define this as a constant. And then we'll use repeaters to loop over each section. And then in this case, just do a synthetic timeout and then push the data to the client. So in our new repeater, we've got push and stop. We'll loop over each message and then we'll push it to the client. Then we'll wait for 1 second and we'll do that until all the messages have been pushed. Once we've done that, we call stop, which will close the connection, and then everything's cleaned up. So looking back at our basic example now, we can see that when we refresh the page, we just get a loading indicator for 4 seconds as all of the data is being streamed in. That's because we've not added the stream directive yet. So if we just add stream to messages, you can see that now we get the data coming in one block at a time. So if I refresh again and show you that, so the data comes in one block at a time. Now, this is obviously a very simple example, so I'll show you a more practical example by now configuring the chat interface. So looking back at our schema, we want to implement a new type just called message. In this case, content is now an array of strings because this is what we're going to stream back to the user. So as we get each response from our chatbot, we'll stream it one word at a time back to the user. We'll define a new mutation called send message. This will accept a message from the user, we'll send it to our chatbot, and then when we get a response, we'll send that back to the client. I've also already set up the chatbot. I'm just using OpenAI in this case, so I've defined a new client. I've got a method here called send message, and I'm going to send the message to OpenAI. I'm using the model GPT-4o Mini, and crucially, I'm setting stream to true. That means that rather than sending back the response as text, we get it as a stream. So as it becomes available, we'll start getting chunks of data. We can use this along with the repeater method to send the data directly to the client as it becomes available. So looking back at our resolvers, let's just return an empty array for this dummy example. And now let's import 3 new modules. So I'm going to use UUID to generate a random ID for each of our messages. I'll input the chat helper that I just mentioned. And then I'm also generating types with CodeGen. So I want to apply this to my resolvers. If you're not using TypeScript, then no problem. But in this case, it just gives me type hints, so it makes things a little bit easier. So I'll create a new mutation called send message. The first thing we want to do is send the message to chatbot. So we get a new argument message and we send that to our chatbot and we get a stream response. We will return the message as an object with our random ID, and then content, in this case, rather than being any kind of text, we're going to return the repeater. We'll set the type to be string, so that means we need to push strings to the push method. Then we'll loop over each chunk from the stream. So we're using a for await loop, which means that every time we get new data coming back from the stream, we'll loop over. We'll grab the data from each chunk. In the case of OpenAI, this is always an array of choices. So we'll just grab the first choice and then get the content from there. If that content does exist, we'll push it to the client. And then when we're done with all of the chunks, we'll just call stop. Because I'm using TypeScript, we'll get an error message here because it expects content to be an array of strings, but in our case, it's actually a repeater, so we just need to cast that type to be an array of strings as well. Now, we also have a basic chat interface here, which I'll just explain. So we've got our text area being rendered here and our send button. We're defining state for two different things, the messages themselves, so the messages from both the user and the AI, and we've also got a control input for the text field. We're then rendering those messages in the component. When the user presses send, we'll call the handle submit function, which will push the user's message to the array of messages. Then we'll send the message to the server, and once we have a response, we'll also push that to the same state. Then we'll clear the message input so the user can send another message. So now I can send a message to the chatbot and I just get a response. But you'll notice it comes back as a single chunk, even though we've implemented that repeater pattern. So the first thing I need to do is apply the stream directive to content. With that in place, you'll see that we still have the same problem. The data just comes back in one go. And the reason for this is that in my case, I'm using the Urkel library, the use mutation hook. The reason I'm using Urkel is because it supports things like stream and defer. But when the data is coming back from the server, it's coming back one chunk at a time. And in our case, we're waiting for the promise itself to resolve. This will only resolve once we have every chunk and we've called stop and the connection closes. But we want to render data in the component as it becomes available. So the first thing we need to do is not await this promise. So we'll send our message to the server as usual, but we won't await for it. We then don't need this block of code at all, so we delete that. What we'll do instead is say that when the user sends a message, we'll also append a second message from the chatbot, but we'll give it an empty string in this case. We can then get the data from the hook itself, and crucially, the data that comes from here will update every time a chunk becomes available. So this component will re-render every time new data becomes available in the data object. We can then use a use effect to say that every time we get new data, push it to the last message. So if that is not available, we'll just return early. I'll just make sure that's imported as well. And then we'll say that we'll replace the last message. In this case, we'll take all the messages minus the last message. We'll re-add it, but in this case, with the new data. And what this results in is that I can now type a message like how to cook pasta, and you'll see that we're getting the data back as it becomes available. Now, if I remove the stream directive and send that message again, how to cook pasta, you'll see that we have to wait for quite a while for all the data to become available before we can render it in our component. So I think that was about 5 seconds that we waited. And obviously the main benefit of streams is that we can start showing information to users immediately. So if I add stream back and then test that, so let's say we waited 5 seconds without streams, and then I'll type the message again. You can see there we wait like half a second and then we're starting to get data come through. So this is one of the main benefits of streams in this case because it drastically improves the user experience. Now I'll upload all of this code to GitHub so you can check it out and run the example yourself if you like. But that is just a very simple example of the stream directive. So I'll just quickly go over what we did. We imported plugin defer stream. We applied it as a plugin to our Yoga server. In our resolver, we've set up a new mutation called send message. The content of that message is an array of strings. For the content, rather than return the array directly, we define a new repeater. We send a message to our chatbot and return a stream. We loop over that stream using for await. And for each chunk, we send the data back to the client using push. Inside the client code, we apply the stream directive to content. We then grab data directly from the use mutation hook rather than awaiting for the promise to resolve. We then apply a use effect so that as we get new data, we can append it to our local state. I hope that video helped, guys. If you want to see more like it, then please comment and subscribe, and I'll see you in the next one. Cheers.